Hello friends, very good evening. Myself Dr. M.H. Chennaya. In this video, we are going to work out the development of the lateral surface of a pentagonal pyramid resting on its base on HP and it's being cut by a section plane which is vertical. In other words, that section plane is seen as a line in the top view and this is perpendicular to HP. So let us split the question into two parts. Part 1, we are going to draw the front and top views of the pyramid to the given condition. So it is a pentagonal pyramid having side of base 30 mm and height is 60 mm. I have marked that height. Rests on its base on HP such that the slant edge, one of the slant edge, there are 5 slant edges. Suppose if I mark it as A, this is B, C, D, and E. These are the 5 slant edges. It has to be placed on HP such that one of the slant edges, say this OD is parallel to VP, and this will give you O dash, D dash, the front view of that, and in fact this will also give you the true length. I am joining this O, the vertex, to all the corners A, B, C, D, and E. And I am going to write this section plane which is vertical, that is seen as a line in the top view at a distance of 10 millimeter from the axis of the vertex. So it is 10 mm from there. And this section plane I have marked here is cutting the base edge at these 2 points and the slant edges OB and OD at this. So there are totally 4 points that appear in the development. Next, to commence the development, friends, we have to retain the larger part which is shown by color portion above this, and this is the portion that is removed after the solid is cut by the section plane. Now we will draw the development of this pentagonal pyramid making use of this true length O dash D dash, that is the true length of the slant edge. Here OD is one of the slant edges, it is parallel to VP, and then this will give you true length, and hence I have marked this as TL. TL means true length. Now friends, I am going to just mark a line, say a vertical line or whatever, a line of length is equal to this O dash D dash. So that much length I will take. I will mark this as O, taking O as center and this true length as radius. I am going to draw an arc. And on this arc lie these 5 edges AB, BC, CD, DE and EA. So I will step off 5 divisions, 30 millimeter each. Say this is 1, this is the second, the third, the fourth, and say one more, the fifth. So these are all the divisions made on this sector, and friends, we will join this to the last point, and through all these points, say A, B, C, D, E, etc., we will draw the lines joining that point to the vertex. So this is one such line, second, third, this is fourth and fifth. 1, 2, 3, 4, 5. All these have the equal measurement. This is how the development will look, but we have to join these corners by straight edges because any of the pyramids will have the straight edges in the base. Now friends, let's see here. See the top view of this, a portion of OB, that is this portion of OC, portion of this DC, these are all removed by the section plane. And hence, you can commence the development either from OB or OC or OD. Say I am going to commence from the point B. So I will start this with B, this is C, this is D, E, then comes A, and the last point is B. So this is how we mark that, friends. And here let us join all these base edges, that is such as OA, OE and OD are retained. OA is retained. So I will just darken this and mark by a dark line. OA is retained, OE is retained. So show the base edge like this by a dark line. Then friends, you have got, after this friends, we have OA, OD and OE. OA, OE and OD to be joined by dark line or visible line. So this is also retained. So this part of the pyramid is not touched by the section plane. And friends, let us move on to the points where the section plane is cutting the base edges. So base edge AB is cut here. This is the true length. So on AB, take this measurement from B and mark on that AB. AB is here. I am going to show by a thin line, and after showing that on AB near to B, I am going to mark a point. This is one such point, and that similarly on CD, you have this measurement on CD, the base edge that is nearer to D. On CD, nearer to the point D, we have one more point, that is a point on the base. So I will take this point. So friends, we have marked 2 points on the base, and on this slant edge OB, you can observe here, the section plane is cutting here. This OB is shown by O dash, A dash, B dash. This line you have got here. So you project this line from there to O dash, B dash. So we are going to get a point here. But remember, O dash, A dash or O dash, B dash are not the true length. Hence, this point has to be shifted to the true length line and mark that distance on O dash, B dash from the vertex. So from the vertex, I have to mark this distance on O dash, B dash. So O dash, B dash, OB is here. Another point on OB here at the same distance. So we have to mark these 2 points. So these are on OB. And you forgot point. Finally, you have this OC, slant edge, cut by the section plane. Where is OC? OC is here. That is C dash, E dash. So friends, draw a vertical line from here till it touches that. It could be anywhere very closer to the. So it is cutting here. So friends, shift that point where it is cutting the edge to the last generator and mark on OC only, just on OC. Point OC is here. So almost at the same height, see. Friends, you have got these points marked on OA, OB, OB and then OC. We have got so many points, friends. Now join all these points by straight line. So I am going to join these two by a straight line. This part is retained. And friends, O is still there. So we have to join this also by a straight line. So OB is over. This portion of OB is also be shown because that is a common point on both. Then friends, join these two. The portion on OC below that point is removed. So this has to exist, darken this portion. Then friends, on DC nearer to D, on DC nearer to D, that point is there, join that also by a straight line and this portion is retained. And friends, we have joined all the points and let us check once which portion of the pyramid is still remaining. If you observe friends one by one, OA has to be full. Just observe, OA is a full line. So this has to be shown by visible line. OE is also full. O to E is full in the development. O to D is also full. O to D. So these are the triangles you get. Two triangles, that is, these two are retained completely. And friends, portion below this on AB, B to that point is removed. On OB, this portion does not exist. This does not exist. This doesn't exist. So you have to just show them by very thin lines. Friends, this is how you will get the development of P, the larger part, this part of the pyramid, which is cut by a vertical section plane at a distance of 10 millimeter from the vertex. Friends, please go through the complete video without skipping anything or any part of it in between. And if you like this video, share with your friends. I thank you very much for watching my YouTube video. Have a nice day.